Hello there guys, welcome to this video where we're going to be taking a look at the definition of the derivative. So let's get right into it. Okay, to start off guys, let's understand what the derivative actually means. So the derivative is nothing, but it's a gradient function. So the derivative of a function is the gradient function. And now, what is the gradient of a function? Now the gradient is simply just a measure of steepness. So it's a measure of how steep a line is. Is it really, really shallow or is it really, really steep? Okay, so it's simply just a measure of steepness. So the derivative is simply a function that measures the steepness of another function. So it's a function that measures the steepness of another function. Okay, so simple. So now, if I have a straight line like this, how can I measure the steepness of this line? Or how can I find the gradient of this line? Okay, well, if I pick 2 points, okay, and I form a triangle like this, well, I could say this is change in y. That's how much it moves in the y direction. That's change in x, how much it moves in the x direction. And it's also known as rise and run. All I can do is I can do rise over run, right? I could do change in y over change in x. So the gradient for a line, for a straight line, is just change in y over change in x, and that's for a line. And so the derivative of a line is just rise over run. It's just this function change in y by change in x. So guys, imagine I have a curve like this. Something like that, okay? So I have a curved line here, and let's say I want to find the gradient at this point right here. Okay, so what am I going to do to find the gradient at that point right here? Now the key intuition here is the gradient at a point, at any point on a line, is the same as the gradient of the tangent at that point. Okay, so the same as the gradient of the tangent at that point. Now what is the tangent? Well, the tangent is just a line, okay, like this, that touches only the point. Okay, so that only touches the point like this. Okay, so let's set this up. So I'm going to pick this point right here and label them like this. And I've labeled it x here and x plus h here. And you'll understand why I did that in a second. So essentially this gap here is just going to be h. So what we can do is do the same thing as we did with the line, right? We picked 2 points, we found the change in y, we found the change in x, and we did change in y divided by change in x. So we're going to do the same thing here. So all I'm going to do is connect these 2 points here and draw a triangle like this. And so essentially, this is our change in y, that's our change in x. So the gradient of that point, at least an approximation to it, is the change in y there over the change in x. Well, what is the change in y? I know that this point here is just going to be f of x plus h, given that this is y equals f of x, sorry. And I know that this point here is just f of x. Okay, so let's work out what change in y over change in x is. It is simply, change in y is just f of x plus h minus f of x. Okay, and change in x is just h, right? Because it's just x plus h minus x, which is just h. But the issue is, do you guys see how this blue line is way off from this green line that we have here? We've said that that green line, the gradient of that green line should be the gradient at this point here. But they are different. So it can't be the same gradient. It's just an approximation. So what can we do to make it more accurate? So let me just clear this up for you guys. Okay, so to make it more accurate, notice what happens when I move this point a bit closer. So I'm going to move this f of x plus h a bit closer like this. I'm going to draw my tangent line like this. And do you guys see how this line here is much closer to this tangent line now? Okay, Perfect. Now let me just keep going. Let me draw my point there. And the same thing, I'm going to draw my line connecting them. Okay, wow. So it's getting much, much closer. Okay. The closer I get to this point, it's getting much closer to this tangent line that I have here. So if I put a point there, of course, it's going to be even closer. So the closer I get to this point here, the closer these lines get to the tangent. So let me just pen that down. So the closer we get, so this is the main key intuition of the derivative to the point. Okay, the closer we get to the point x f of x, the closer we get to the gradient at that point. Okay, so it's very, very key intuition right here. Okay, so how can we represent that mathematically? Notice what is happening is that we're actually moving this point closer to the x point. In other words, we're shrinking the value of h. And mathematically, that is written like this. It's written like the limit as h goes to 0 of f of x plus h minus f of x all divided by h. Okay, so this is how the idea that we just discussed is written mathematically right here. And this is the main idea behind the derivative. Okay, so the closer we get to this x point, the closer the smaller we make h, the closer we get to the gradient of this point. Perfect, amazing. And that is the derivative. So the derivative, and it has many, many ways of writing it down. So this change in y by change in x becomes dy by dx. Okay, it changes from this change delta symbol to dy by dx. And that is equal to, it just becomes the limit as h goes to 0, which is the idea of getting closer and closer to this point. So shrinking our h right here, of simply f of x plus h minus f of x all divided by h. In other words, the top is simply just your change in y, and the bottom is simply just your change in x. Okay, so you have a change in y and the change in x from before. And perfect. This is our derivative, guys. Hope you guys understand what the derivative is now. And please feel free to ask any questions in the comments below if you have any questions. And so the one last thing that I wanted to tell you guys is that there are many ways to write this derivative here. So you can write it as f dash of x. Obviously dy by dx itself is one way to write it, but it's commonly written as f dash of x. Because remember, at the end of the day, this here is a function in itself. It is the gradient function, okay? So if what that means is, if I was to put in x equals 2 into this function, and I was to work out the value of that right there, I'll get the gradient. So I'm going to get the gradient at x equal 2. Okay, so if I put in x equal 2 in there, I get the gradient at x equals to 2. And now working this out will be another video in itself, which I'm hoping to make in the future. But for now, I hope you understand the definition of where it comes from and the intuition behind it. Okay, thank you very much for watching this video, guys. Please like and subscribe, and I'll see you guys in the next video.